Hi, this is section 3.1 that we've recorded. We're starting back into fractions. We've done this already, so we're not going to go through every single thing. We'll just go through a little bit of review and continue on with what we need to be doing. Okay, we're going to determine proper and improper fractions. We've done this before, right? So if I have the fraction 3/4, I would ask, is that improper or proper? And you would say it's a proper fraction because the numerator is smaller than the denominator, right? 3 is less than 4. Or in other words, hey, how do you like my neat highlighters this time? Woohoo! If I color in 3 sections out of 4 to make that whole, it all fits inside of 1. But if I have a fraction like 5/2, the numerator is 5 and the denominator is 2. Improper, right? I think your assignment has you determine some of those things. But I'm going to color in 5/2. 1, 2, 3, 4, 5. Well, that's way more than 1 whole. In fact, that's 2.5, right? So that determines that the fraction is an improper fraction. So I'll scoot that up. I think we can see that. Equivalent fractions represent the same part of a whole, right? So I want to color in the same part of the pie. Let's say I wanted to eat this much of my pie. Now, it's the same amount in every single pie, even though I cut them into different size slices, right? In this slice, it's 1 out of 2 pieces. In this pie, it's 2 out of 4. In that pie, it's 3 out of 6. And in this pie, it's 4 out of 8, right? All 4 of those fractions represent the exact same amount of a whole. So let's come over to this piece of pie here. I only want that much of it this time. But I've cut them differently again, right? So if I ate 1/3 of this pie, but then I cut it into smaller pieces. If I ate 2/6 of that pie, I ate the same amount both times. So equivalent fractions mean the same thing, even if they're not the exact same number. So let's move on here. We're going to talk about writing fractions with a denominator. This time let's make a denominator of 6. So first we'll do 1/2. We've done this before, right? We want to figure out how to make this fraction the same or an equivalent fraction to 1/2, but with a denominator of 6. We've done this before, so we know we need to multiply 1/2 by what number? Yep, 3, because 2 times 3 is 6. So we have to multiply it by 3 in the numerator and 3 in the denominator, because we know that's the same thing as multiplying by 1, right? So 1 times 3 is 3, 2 times 3 is 6, 1/2 is the same thing as 3/6, we know that. And we've done that already, but this is what we haven't done. Oh, I want to make this fraction 20 over 30. I want to make that into a fraction with a denominator of 6. Wait a minute, I can't multiply that by a number and get a smaller number, can I? So what will I do? Yep, you're right, I knew you'd guess it. This time I have to divide by a fraction equivalent to 1, right? But what will I divide by? 30 divided by some number equals 6. I know that one. 5. As long as we divide both the top and the bottom by 5, we're good. We'll have an equivalent fraction, right? 20 divided by 5 is 4. 30 divided by 5 is 6. Hey, I found an equivalent fraction and I made it with a denominator of 6. Let's do that one more time, right? Let's make these fractions have a denominator of 10. Let's start with 21 over 70. Somehow I want to end up with a denominator of 10, right? So what do? Obviously, I have to divide because 70 times some number does not equal 10. However, 70 divided by 7 does equal 10. So I have to divide both the top and the bottom by 7, right? 21 divided by 7 is 3. Ha! That worked. Same thing as 3/5. I think that will work. We want to have a denominator of 10 in the bottom, but this time we don't have to divide. We can multiply. by what number? 5 times what number is 10? 2. And 3 times 2 is 6. That's an equivalent fraction, 3/5 and 6/10, but we have a denominator of 10. So why do we want to do this? Because we have to be able to put fractions in descending order, and they're not going to be the same fractions. All right, let's start with 1/2 and 1/6 and 1/4 and 5/12. Now, what if I'm asked to write these fractions in descending order? Well, I could look at my chart, and I can draw a chart every single time I want to do this and figure it out. Or I can write each fraction as an equivalent fraction with a denominator of 12. Why? Because 2 divides evenly into 12, 6 divides evenly into 12, 4 divides evenly into 12, and 12, of course. 5/12 is already in with a denominator of 12. So how do we make 1/2 have a denominator of 12? I know. We can multiply both the top and the bottom by 6, right? 2 times 6 is 12, so 1 times 6 is 6. How do I make 1/6 turn into some number fraction with a denominator of 12? Well, we just did that, right? Divide times both the top and the bottom by 2. 6 times 2 is 12. 1 times 2 is 2. 2/12 is equivalent to 1/6. 4, 1/4, and I know that 4 times 3 is 12, times top and the bottom by 3. 1 times 3 is 3. 4 times 3 is 12, and 5/12 is already written with a denominator of 12, so we're good. But now we want to put these in order, right? We got to figure this out. Which is the smallest out of these 4 fractions? Well, I bet you that 2/12, which, guess what? We didn't call that 2/12, did we? We called that 1/6. So our very smallest or least fraction right here would be 1/6, which is what we called 2/12, but it's 1/6. And that happens to be less than, what's our next fraction? Well, not 6, not 5, it would be 3/12, which is 1/4. So 1/4 is greater than 1/6, or 1/6 is less than 1/4, right? We're good. 5/12 is our next one. And 1/4 happens to be less than 5/12. And then our very biggest fraction among these fractions happens to be 1/2, or 1/6 out of 12, right? So 5/2 is less than, or 5/12 is less than 1/2. So in other words, if we get the denominator to be the same for all the fractions that we have to put in order, we'll be able to figure out easily what order they go in. So that is Chapter 3, Section 1. So do the assignment, look on your assignment grid, and do the exercises assigned for Section 1.